my channel. We will be doing question number 13 right now. Okay, so it is a bit interesting question. Question number 13. It has two parts. So part A says that we are given a curve y equals e to the power 3x into 2x plus 3 power 6. Okay, and we need to find the stationary points on this curve. Okay, so stationary points are where the derivative is equal to 0, and that those points are either maximum or minimum. Okay, so we need to find the derivative first of all. So dy by dx equals first function. I will make this part first function and this part second function. So first function into derivative of the second function, that is going to be 6, and 2x plus 3 power 5, and the derivative of this is going to be 2 only, plus, so first function derivative of second function plus second function is 2x plus 3 power 6 into derivative of the first function, so that's going to be e to the power 3x into 3. Okay, so if we try to simplify it a little bit, so it's going to be 6 to the 12 e to the power 3x into 2x plus 3 power 5 and plus 3 e to the power 3x into 2x plus 3 power 6. So I can take 3 e to the power 3x and 2x plus 3 power 5 as common outside. So I have only 4 from this first thing, and plus from the second thing I will have only 2x plus 3 power 1. Okay, so from here we can see this is 3 e to the power 3x into 2x plus 3 power 5 into, this is going to be 2x plus 7. Okay, and in order to find the stationary points, we need to substitute, we need to make this thing equal to 0. And now this expression is going to be 0 if e to the power 3x is 0, or 2x plus 3 is 0, or 2x plus 7 is 0. Okay, from here we see that the x has to be negative infinity. From here, x is equal to minus 3 by 2, which is minus 1.5. And from here, x is equal to minus 7 by 2, which is minus 3.5. Okay, so these are the three, in fact, there are the two stationary points. Okay, so if x is minus 1.5, what is going to the value of y? Y would be e to the power 3 into minus 1.5. This is the value of x into 2 times minus 1.5 plus 3 power 6. So this is going to be e to the power minus 4.5. Okay, let me make sure that I did the same thing. And okay, 2 times 1.5. What am I doing? 2 times 1.5, yes. So that is going to be 0. So this is 0. Okay, and if x is equal to minus 3.5, then y is going to be e to the power 3 into minus 3.5 and into 2 times minus 3.5 plus 3 power 6. So this is going to be e to the power minus 3 times 3.5, and here I will have 2 times 3.5 is 7 minus 7 plus 3. This is minus 4 power 6. And when we evaluate this whole thing, minus 4 power 6, this comes out to be 0.113. So the two coordinates for the stationary points, x is minus 1.5 and y is 0. And the second coordinate is x is minus 3.5 and y is 0.113. So this is our answer for part A. Okay, let me show you graphically what do we mean. I will try to sketch this given curve. This curve, I will try to sketch it. Let me show you. Okay, so yeah, this is the sketch of the function. And you can see that it has two stationary points. One is at x equal to minus 3.5 and the other one is at x equal to minus 1.5. And when x is minus 3.5, the coordinate of the stationary point is this one. And when x was minus 1.5, the coordinate of the stationary point is this thing, y is equal to 0. Okay, so you can see the stationary points is with the curve is either maximum or minimum. Okay, so this was our part 1. Now I need to make some space to do part 2. Okay, let me erase everything. Okay, so okay, good. Mm, okay, so going back to part B. Okay, so part B of this problem is that there's a curve. We do not know its exact shape, but we are given that its derivative of this function at 0.5 is 0 and derivative of this function at 3 is 0. Okay, so from this information we can see that whatever the shape of my curve, it is at 0.5 we have one stationary point, and at 3 we have another stationary point. So the curve is either maximum at this axis 0.5 or minimum at 0.5, and similarly at 3 it is either maximum or minimum. So this is one thing. Second thing, we know that the second derivative of this function, it is given by 4x minus 7. This is interesting information. Okay, so at x equal to 0.5, we know that the first derivative at 0.5 is 0. What about second derivative? Second derivative at 0.5. You see, so second derivative at 0.5 is going to be 4 times 0.5 minus 7. So this is going to be 2 minus 7, so it's minus 5. Okay, and we talked about it before that if the second derivative is less than 0, if it is negative, okay, then it is going to be a maximum point. Okay, in the same way, at x equal to 3, we are given that the first derivative at 3 is 0, which means we have a stationary point over here, and the second derivative at 3, what is it going to be? It's going to be 4 times 3 minus 7, so it is 12 minus 7 is going to be 5, and 5 is positive. So from here we conclude that the at x equal to 3, we have a minimum point. Okay, so the curve is going to be something like this and like this. So at 3, we have a stationary point which is minimum, and at 0.5, we have a stationary point which is maximum. Okay, So I hope this is very easy, very it's clear, everything is clear. If you have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.